B. Find the speed when x is 0.025 meters. Now, what happened is, this is the initial position of the block, stretch until 0.5 meter, and we stop there. Then we release the block. When you release the block travels back to the equilibrium position. But before it reaches the equilibrium position, at a position of 0.025 meters away from the equilibrium position, we stop there. Not the block cannot stop there lah. We use the maybe video camera, then we pause the video. Okay, freeze. So we freeze it there. The block is frozen at this position, and we try to analyze what is the energy in this case. Okay, what is the total energy in this case? And we try to find, using this energy equation, how much is the velocity before it reaches the equilibrium position, right? Somewhere before, halfway lah. This is 0.5, 0.05, this is 0.025. So actually it's midway lah, midway between the initial position and the equilibrium position. So how much is the energy? Okay, how much is the velocity? So we are going to use the same method. Find all the three energies, total them up. Find all the three energies, total them up, and say, oh, conservation of energy. So we try to equate the two and try to solve for the value of V. Okay, right. So this is what we're going to do, right? Okay, let's say this position, okay? Let's say this position, the final position, okay? Now, when the block is moving back to the center, to the equilibrium position, the kinetic energy is not zero because it is moving. Gravitational potential energy is zero because they are at the same horizontal level. They didn't move up or down, so it's the same, right? So it's zero. Then we talk about the spring energy. The spring energy is not zero. It still has some energy stored because it has not reached the equilibrium position. Only when it reached the equilibrium position, then the spring energy is zero. Okay, so we are going to equate them. Initial position, okay, we are referring to this one. Kinetic energy, zero. Kinetic energy, zero. Potential energy, gravitational potential energy, zero. Potential energy in the spring, half kx squared. All these three, we are referring to the initial position. Okay, then final position. Okay, final position, kinetic energy, half mv squared. Midway through, half mv squared. Gravitational potential energy, zero. Elastic potential energy in the spring, half kx squared. Of course, the x here is the initial x. The x here is the final x. Different x, they are different x. So substituting k equals to 400, x is 0.05, just leave it there. Half mv squared, half, m is 5, v is v. Then the spring potential energy, half, k is 400, x is now 0.025. Okay, so we are going to solve this equation, move this number to the other side, try to find out what is v squared. So v is the square root of these numbers. The answer is 0.387 meter per second. Any question?
No question, sir.
No question. Okay. No question. We're going to